the operator. Whom do I have online? Excuse me, this is the operator. I do need your name for the conference. Please check your mute button. Do I have anyone online?
Welcome to the conference calling center.
Welcome and thank you for standing by. At this time, all participants are on a listen-only mode. During the question and answer session, please press star 1 on your phone to ask a question. Today's conference is being recorded. If you do have any objections, please disconnect at this time. I would now like to turn the call over to Gray Halatulama. Please, sir, you may begin.
Thanks. Yes, hi, this is Gray Halatulama from the NASA Headquarters Office of Communications, and welcome to our announcement today of the delivery award for the VIPER rover to the moon's surface through NASA's Commercial Lunar Payload Services Initiative. With us today is Thomas Zurbuchen, head of NASA's Science Mission Directorate, Lori Glaze, the Planetary Science Division Director at NASA Headquarters, and our winner, who we will introduce shortly. Also available online to answer questions will be Steve Clark, who was the Deputy Associate Administrator for Exploration and Science when this award was selected. He's now the Deputy Associate Administrator in Aeronautics. We have Dan Andrews, Project Manager for the VIPER mission at the Ames Research Center in California. Chris Culbert, the CLIPS Project Manager at the Johnson Space Center in Houston. And Sarah Noble, the VIPER Project Scientist at NASA Headquarters in Washington. And again, while people are talking, you can feel free to press star 1, and that will get you in the queue for questions. With that, I'm going to turn it over to Thomas Zurbuchen.
Well, thanks, Gray. I'm really happy to be here today and to announce another milestone in our Commercial Lunar Payload Services Initiative, which we refer to as CLIPS. It's a milestone with great implications for science and for our Artemis program to send the first woman and next man to the moon in 2024. Beginning next year, our industry partners will begin to deliver payloads to the lunar surface for NASA and other customers. These payloads will advance lunar science, test technologies, and demonstrate capabilities to help NASA explore the moon and prepare for those Artemis missions with astronauts. This cutting-edge program and the innovation of our partners and their systems is going to provide a steady cadence of payloads and instruments to maximize science value at the moon and to advance exploration technology. An important part of this work is to find out where the water is on the moon and how much of it there is. So today, I'm pleased to announce that our CLIPS partner, Astrobotic, will deliver NASA's VIPER rover to the moon in 2023. The VIPER mission will search for ice and map resources to bring us a significant step closer to NASA's ultimate goal of a sustainable long-term presence on the moon. And this will help make it possible for humans and eventually explore Mars and beyond. VIPER represents a very different development paradigm, developing every instrument for launch on an earlier CLIPS mission, which totally flips on its head how we normally do this. It's truly creative and novel. There are many elements of VIPER and CLIPS that showcase the ways we are working differently to achieve our lunar exploration goals. We'll talk about some of them today, and I hope you'll also go to the VIPER and CLIPS websites to learn more. We look forward to your questions, and now I'd like to turn it over to Lori Glaze, followed by John Thornton, the CEO of Astrobotic. Go ahead, Lori.
Great. Thank you, Thomas. Scientists have been studying the moon, for decades now with orbiters and even an impactor mission. We've landed there with humans and robots, and we're going back. We've learned a lot from all of our missions, but maybe one of the most surprising findings of recent years was that the water ice has accumulated in the extremely cold, permanently shadowed regions of the moon, one of the coldest places in our solar system. This water ice could potentially be used by future human exploration missions, but we don't know how it's distributed or what form it's in. It might be found as ice crystals or as water molecules chemically bound to other materials. And this is where VIPER comes in. VIPER is going to roam over several miles of the lunar surface and use its science instruments to detect water molecules on and below the moon's surface, and also use its drill to go below the surface and tell us more about the location and physical state of water, an incredibly valuable resource at the moon's poles. Scientific data gathered by VIPER is going to contribute to the selection of future landing sites under the Artemis program by helping us to determine locations where water, ice, and other resources could be harvested to sustain humans over extended stays. The rover is also going to help us prepare for human exploration by providing information on the environment at the lunar poles, including the temperature and lighting conditions, and the ability for future rovers to traverse through its soil. Now, back to the science. We are so excited about. By helping us understand the distribution, the physical state, the composition of the water that VIPER finds, the scientists are also going to be learning about the origin and history of that water on the moon, as well as discovering new insights into the evolution of the moon and the Earth-Moon system. So that's a lot for this rover to accomplish, and we're very excited about its mission, and of course very excited about this new partnership that's going to deliver VIPER to the lunar surface. So now I'd like to toss it over to John Thornton, Astrobotic CEO. Take it, John.
Thank you, Laurie, and thank you, Thomas. Today marks another exciting milestone for a new era of science, exploration, and commerce on the moon. Astrobotic is just so thrilled and grateful to be selected by NASA to deliver the VIPER rover. The rover will no doubt be a historic mission, and as we've already heard, its findings on lunar water ice resources could have far-reaching implications for enabling our future in space. When we founded Astrobotic 13 years ago, we did so with the aim of making the moon accessible to the world. This opportunity to deliver VIPER to the pole of the moon with our Griffin lander is truly a dream come true. VIPER will be Astrobotic's second CLIPS delivery following our Peregrine lander delivery in 2021. Today's announcement brings our total booked payload count to 26 across all of our lander mission manifest. We congratulate NASA for its bold leadership in working with commercial companies and for capitalizing on all of the momentum occurring in the lunar market. And our highly motivated team in Pittsburgh stands ready to make NASA and the nation proud.
All right. Thanks, Mr. Thornton. Appreciate that. All right, everybody. We can ask questions now. Again, press *1, and we will take them in the order that we receive them. And I see we're still waiting for people to give some questions. Thomas, do you want to talk a little bit more about CLIPS and how it's sort of a different paradigm and cutting-edge way of procuring these services and getting to the moon quicker?
Yeah, I mean, I have to tell you, we're still in the afterglow here of Demo 2, and Demo 2 is just like, a commercial crew, just like commercial cargo. Really, I thought it was just a bold experiment that from our colleagues from the human exploration side to really look at these important activities as services that we could use. At this moment in time, the Demo 2, with its tremendous success, has also shown that together with the crew, is really just, a massive success, bringing the commercial capability to bear of the United States to these important activities that we want to do at NASA. And the CLIPS for us is really utilizing this similar approach, of course, adapting it for this because we believe that the moon will be a really important destination to go forward, just like the space station is today. I love this model. Let me just add one more thing, which is really the development paradigm. Look at all missions across of SMD, and I can tell you basically almost without any exception, if you wait long enough, an instrument is on the critical path to finishing a mission. The ability for us to really pre-fly those instruments using the CLIPS landers ahead of VIPER, just really changes the instrument. It changes the entire paradigm and really helps us taking, if you want, the largest schedule risks off the table and really accelerate the development of VIPER in a way that would otherwise not be possible. So it's just really one of many ways this CLIPS program has helped. Great, back to you.
Okay, thanks, Thomas. We're getting some questions now. Operator, you can go through the list.
Thank you. Our first question comes from Leonard David. Sir, you may ask your question and please state your affiliation.
Hi, thanks for having this. Leonard David with Scientific American. I've been working on a story and looking at also the lunar CubeSat community, and will the management of all this looking for water ice, will it utilize CubeSat, LRO, along with VIPER?
Lori, is that a question you might be able to answer, or is that for Thomas?
I think that probably myself and Steve Clark can probably take some of this. As far as using lunar CubeSats, there's certainly a lot of capabilities there. We have one that is currently under development that Steve Clark and I have been overseeing and watching, called the Lunar Trailblazer, which carries infrared spectrometer that can map out water-bearing molecules on the surface of the moon. I think there's a big role that the smaller spacecraft can play in doing that. And of course, LRO has already made huge contributions there with the neutron spectrometer that has mapped out hydrogen on the moon. So I think there's certainly a lot of great opportunities there, and I don't know if Steve wants to speak a little more to that.
Thank you, Lori, and I completely agree with you. I'm excited about the prospects of using smaller spacecraft platforms to get the valuable scientific data that we continue to want to acquire for the research community. I'll also add that there are some CubeSats that are going to be flying on the first Artemis mission, the unmanned mission, Artemis 1, that will be deploying some CubeSats into lunar orbit to do some measurements as well. And so we expect to have what I'd call robust interest from the community to fly smaller platforms to acquire this scientific data. And we're going to continue to see that. Back to you, Greg.
So, this is John Thornton. If I could just jump in just to add a quick point there is LRO is also a key enabler for the mission. The precision landing at the poles is going to be key for this because the polar lights are all cast at low angle, and we have to deliver the VIPER rover to the correct location so that it can then stay in the light and do its operation to then drill for water in the poles. And all of that is enabled by the very high resolution imagery that's come from LRO. So LRO is a great building block and an enabler, and just one of many that NASA is developing.
Thanks, John.
Okay, thanks, everybody. Next question.
Thank you. Our next question comes from Megan Bartels. You may ask your question and please state your affiliation.
Thanks for taking my question. I'm Megan Bartels with Space.com. I had a question about the launch likely for Dr. Zurbuchen. In late February, you were saying that the launch had slipped to early 2023, and in the release for this call, it said late 2023. And I was wondering if you could talk about that delay, what caused it, and whether that will leave VIPER enough time to get NASA the info it needs before humans attempt the landing.
Thank you so much for the question. Yes, it will leave enough time for VIPER to do the important mission that is there. We've carefully looked at this. The most important change that we made there, it was really to actually ask the team to basically equip VIPER with capability to survive the night and therefore enhance the mission length. As we thought after looking at the investment that it would take there and kind of considering what's the standard out there, that change that was worth waiting for because of its enhanced science potential. The question whether it's earlier or later in the year is entirely about the destination. Whether, scientifically speaking, kind of northern poles and the southern poles have similar type of, different of course, similar type of science relative to the water distribution. But what we really would like to do is utilize the same kind of pole that we want to use with our crewed mission that will go there in 24. So that's the choice there. But there's nothing that changed since that. The fundamental decision that we announced there was really to equip the rover with that, and also, frankly, looking at an achievable schedule overall that really leads to the result that we expect from VIPER. I don't know whether anybody else from VIPER wants to add a comment.
This is Dan, the PM for VIPER, and I'd like to confirm everything Thomas just shared there. We have been standing on the shoulders of investments the agency made earlier on a lunar polar region mission, and it simply had a different set of requirements that was being pursued. Now with the update to make it through multiple lunar days, extend the overall mission by a factor of 3 as far as duration goes, we had to go back and take a look at the design and update things, as well as now, starting today, working with our CLIPS partner to make sure that we have a fully compatible system as we go forward to the moon.
Great, thank you. And just a quick clarification on what you were saying, Dr. Zurbuchen. The late 2022 and the late 2023 dates would both be to the South Pole, and the early 2023 date would have been to the North Pole. Is that correct, or did I misinterpret that?
Dan, please just make sure you clarify it on your end too.
Yes, that is correct.
Okay, thank you.
Thank you. Our next question comes from Mark Kerbo. You may ask your question and please state your affiliation.
Thank you. Mark Kerbo with Aviation Week and Space Technology. I have 2 questions. Could you provide an estimated overall mission cost, and to what extent might the findings you get from the VIPER rover help refine where you land Artemis 3?
Laura, do you want to take the cost one?
Well, Gray, I could do that if you'd like, and Chris Colbert can amplify as well. But yeah, you'll see that the announcement was for the CLIPS delivery, which is end-to-end for $199.5 million. And this is a firm fixed price award, and it includes the launch vehicle transportation services. And as I said, it's end-to-end. So that is the delivery cost to launch VIPER and deliver it to the surface of the moon at the South Pole. Chris, did you want to amplify anything on that?
No, that's a good summary. Steve, thanks.
Back to you, Greg. And Mark had that second
part of your question again, Mark?
Well, I really wanted an estimate for the mission cost, in other words, more than just the launch services. But my other question was to what extent the findings that VIPER provides might refine where you land Artemis 3.
I can take that, Mark. And just to clarify, the 199.5 is the launch vehicle and the lander delivery services as well. So it's an overall end-to-end. It's not just the launch vehicle cost. But certainly on your second question, as Thomas was saying in the beginning, and Lori, that VIPER is going to be the first robot to actually touch this water ice that we've detected from many different previous missions, and including LRO that's currently still working after 10 years, providing us fantastic data. So this will be the first rover to actually touch the water ice and start trying to determine the distribution. What's how much of it is there? How deep is it to get to? and so forth like that. So certainly, I think VIPER is a game changer here for our ability to start knowing more and gaining more insight into this water ice that we've detected. And certainly the data that we get back from VIPER not only will help the research community, but overall will help, and we will share with our human spaceflight colleagues on as we start looking at where in the South Pole region we want to return humans, the first woman and the next man, to the surface. So certainly it will help play into the selection of where we want to send Artemis 3.
Mind if I add a comment to this, Steve? I just really wanted to make one point, and that is, look, Lori talked about the amazing surprise of seeing some of these water resources, both in labs and also remotely, right, through a variety of analysis. And it's also true that both from data on some instruments on LRO as well as other investigations that happen in the meantime, both on U.S. and other spacecraft, we have learned about some of these materials that we think are water, right? And we believe that the evidence has firmed up that it's water. There's a lot unknown about how we translate the remote sensing observations that are there in our databases, are being analyzed by scientists worldwide. How to translate that into knowledge that would really be of importance for somebody who would be interested in the resource context of this. And so in that sense, yes, I think Steve said it well, right? The information that we're getting from VIPER would really give us information not only about the location where we're going, but really generally, we hope and believe, to relate the information that we find with VIPER to information that we have remotely acquired, and they'll help us interpret that in a context that will be even more valuable to human exploration than the VIPER data themselves. So in that sense, absolutely, that information is useful and will be utilized as well others that are already available from LRO and otherwise.
So this is John Thornton with Astrobotics. I can add one comment to that from a commercial perspective. The discovery of water ice at the pole is potentially a massive breakthrough for commercial opportunity in space, because we can turn that water into rocket fuel, and the moon can become a destination for refueling our spacecraft to explore the moon and maybe even go deeper into space. So understanding what that water is from a commercial perspective, as well as all the science perspective, potentially truly unlock the solar system to exploration and science.
And Lori, did you have a clarification too?
I thought I would add. Steve spoke to the cost of the CLIP service, but I think part of the question there had to do with the actual VIPER mission cost. And I would just note that Thomas mentioned that we did ask the team to go back and expand some of the capability as far as being able to survive some of the colder temperatures on the moon. And then, of course, we've adjusted the time frame, the schedule for the mission. So the mission is now still in formulation. It's moving towards it's the point where it'll be confirmed, and at that point we'll be able to speak more confidently about what the overall mission cost is. I just wanted to add that clarification.
Okay, thanks. Next question.
Thank you. Our next question comes from Richard Taboo. Sir, you may ask your question, and please state your affiliation.
Hi, this is Richard Taboo. I'm with the Orlando Sentinel. I have a question, two-part question for John. You're sending your own rover up on a previous CLIPS mission, and I'm wondering if that's going to have any ties to how NASA will operate its mission, or if they're talking to you about that. And then second, I know that for your first CLIPS delivery mission, you are going with Vulcan Centaur for the launch, and I'm wondering if you are going to wait to make a decision on how you're getting there till after that launch. And those are my two questions.
Thank you.
Great, thanks for those. So the second one first is that we have not yet made a launch selection for the VIPER mission, and we will be looking very carefully and closely at that in the coming months, and look for an announcement in probably sometime this year on that one. And then the second, just relating to the rovers, is that yes, we do have a rover flying on a mission prior to VIPER. We also have flying a rover on our first mission, which is a small rover. And I think the key there, that the big takeaways, is that Astrobotic is learning how to integrate rovers, which have unique requirements and unique interests and needs to deploy from the rover, be able to communicate at least a little bit, and then be able to take pictures and things as the rovers are departing. So there's a unique lander-rover interaction, and I think those prior missions definitely give us experience there. And the Moon Ranger rover will actually be flying on another CLIPS provider. Maston is the selected vendor for that one, and that is an award that we were awarded by NASA. So that we're working very closely with NASA on the development of Moon Ranger with the CLIPS office to have that one delivered. So there's a lot of back and forth here, and I think that gives a unique advantage for this mission, given that background and experience to make sure the VIPER is delivered safely to the pole of the moon.
Okay, next question.
Thank you. Our next question comes from Eric Berger. You may ask your question and please state your affiliation.
Hi, good morning. This is Eric Berger with Ars Technica. Congratulations. This is certainly a very exciting mission. I'm wondering, Thomas, if you could talk about sort of the timeline for this mission and how many companies you thought were actually capable of getting a 400-kilogram rover to the surface of the moon in 2023. It strikes me that there are a lot of companies working on this, but that's pretty ambitious, and maybe you could give a sense of, was Astrobotic the only company you thought really had a reasonable chance to pulling this off, or were there half a dozen companies you thought were capable of this? Thank you.
I really thank you for your question, and frankly, I'm going to want to have Steve Clark kind of supplement what I'm saying. I really do believe, Eric, and like you're observing and we're all observing, it's just how rapidly this field is moving forward. And yes, there are multiple companies that are out there who can really do that. Some of them we've worked with, some of them are entirely new, some of them are engaged elsewhere, with much bigger landing systems, as you know, on the human landing side, and so there's multiple of those. But I just want to tell you, it's an exciting view to see how this is moving forward with our U.S. companies and also internationally. I just really believe it's just a rapid development. So if you ask the question you just asked, Eric, you asked them today and you asked them 6 months ago, and I believe in 6 months, the answers will depend on time. Steve, do you want to add details?
Thank you, Thomas. And Eric, yes, we have 14 CLIPS providers on the CLIPS contract. And when we put out a task order or a request for task order plan, all 14 of those providers are eligible to bid. And these providers, they all have different capabilities. And we received, I'd say, a healthy response in those proposals. I won't go into procurement details. And we have a very specific criteria of which we go through to evaluate those proposals when they come in. And Astrobotic was selected based on that criteria. And so as we continue to put out requests for task orders to do what we're looking to have at least 2 deliveries per year. Again, all 14 of those providers can propose, and we'll go through a specific evaluation process based on those bids. Chris Culver, I'm just going to ask if you've got anything more you'd like to add to that process.
I'll just say that to your original question, Eric, about the numbers, let's just say this was a very healthy competition. There were multiple vendors very capable of delivering VIPER.
And that's really the key point, right, Chris and Thomas? That's what we're trying to build here with this commercial business with the CLIPS providers, and the fact that we did get a healthy or robust response is that I think this model is working, and we're really looking forward to seeing the first deliveries next year, and then Masted in 22, and of course our VIPER delivery in 23. So I think this is starting out really well.
Okay, next question.
Thank you. Our next question comes from Joey Roulette. Sir, you may ask your question and please state your affiliation.
Hey, thanks for doing this. Joey Roulette for Reuters. I was wondering what the amount being awarded to Astrobotic is today. And for John, since this is under another commercial-focused program, I was wondering if you could talk a little bit more about the commercial viability of these systems and how this will kind of benefit a commercial future on the moon. Thanks.
So I can take the second part of that question. Maybe NASA wants to answer the first one. So in terms of commercial viability, both Peregrine, which is the first lander that we'll be delivering to the moon, and the Griffin, the second lander that will be delivering VIPER to the moon, both are designed from the ground up to be commercially viable and for the customers that we see all around the world. So even on our first mission, we have multiple other customers that are non-NASA on that mission, which is proof that there is quite a bit of interest and demand from around the world. We saw a surge of interest after the first award last year, and I suspect, again, we will see another surge of interest. But truly, it is international from all over the world, all kinds of interest, big and small, to send things up to the surface of the moon. And these CLIPS opportunities with NASA, of course, are a big part of making that commercial viability. But it truly is unlocking a new commercial paradigm for the moon, and one that we hope that will make flights to the moon a routine, regular kind of thing, so that science and exploration can truly thrive on the moon, and get us eventually to other planets in our solar system like Mars.
Thanks. And Joey, this is Steve Clark. To your first question, the award is for $199.5 million for the end-to-end delivery service to deliver the rover to the surface, and that includes the launch vehicle costs and the lander delivery costs. So that's the end-to-end commercial delivery.
Gotcha. And just to clarify, I guess I meant excluding the launch cost and only the delivery cost. Thanks.
So when and I'll defer to Chris on this too, but when we ask for, with the request for task orders bids, we get the overall cost proposal back as part of, both the technical and the cost information to evaluate. Chris, did you want to add anything more to that?
Yeah, these are firm fixed price proposal structures, so we just see a total price from, in this case, Astrobotic, which would include all the costs for the services. We don't actually see a breakout between launch and everything else.
Thanks.
Okay, thanks. Next question.
Thank you. Our next question comes from Paul Brinkman. Sir, you may ask your question and please state your affiliation.
Yes, hi, Paul Brinkman here with United Press International. Obviously, it's been a little, we haven't sent many rovers to the moon lately, but we have sent them to Mars. And I'm wondering if someone with NASA could say, the VIPER components are to be designed to withstand dust, temperature, lighting, cosmic rays, and to find water ice. Can you talk about how different some of the components may be from Mars rover, since that's what a lot of people are more familiar with? And, obviously, I guess some of that technology built on Mars rover technology, but how might it be different?
Do you mind if I start and then kick it over to the manager, perhaps? The way we built Mars rovers, Perseverance, getting ready to launch in July, right? For example, is a rover that we expect to survive years, highly sophisticated, long-term, kind of survivability for down to the parts level and the system level with, an interdescendant landing system, which of course recognizes that there's an atmosphere at Mars, and with the longer duration, even though there's a thin atmosphere, has a different kind of exposure to environmental effects such as space weather. It's in most of these rovers, certainly the ones that we've done in the last decade or so, are strategic scale missions at the multi-billion-dollar level with advanced instrumentation going forward. What I love about VIPER is, of course, it takes advantage of the knowledge that's there. For example, in some of the software, certain software was developed for this. It has tremendous utility on the VIPER mission. But the way I think about the VIPER mission, it's a highly innovative, lower cost approach to these Mars missions with a very different development paradigm. And so yes, there's applicability from one to the other, and frankly, we've ensured that in the development there's work that our friends from JPL are doing as part of review boards or otherwise that are being available to our good friends at Ames and at Johnson who are building VIPER. But it's really important to us that we actually, the way even we manage it is we manage it much more hands-off to really let it be an innovation experiment. As we're using the innovative delivery, we also want to make sure that we match it with in an innovative development process, because we want to not only, of course, take advantage. We have really built this new capability, I think, as John pointed out, but also really do so by learning how to do things differently and better, kind of appropriate for these commercial capabilities. We want to speed up to do some of our development in this context because we can, right? It's a very different part. But Dan, I'd really like you to add some details, perhaps, or specifics.
You bet. I really appreciate this question and that preamble, Thomas, because what's interesting to me about VIPER is it is very different on multiple fronts. Some of what Thomas was just talking about, the whole development approach that we're taking is a very different approach. It has heritage back to LCROSS and some other missions that are just fundamentally different. And there's going to be a very different cost profile that comes from that, too, in comparison to missions that you're used to. Similarly, this whole CLIPS experiment, right? The whole delivery via commercial service, not just launch vehicle, but the entire end-to-end delivery of VIPER down to the surface of the moon being provided commercially. Really remarkable, pathfinding, especially on the size of VIPER. So that's yet another interesting angle on this. And then the third angle on this, I think, is really closer to your question, which is how might things be different between the development of VIPER and earlier Mars rovers? And even that topic itself is probably worthy of an hour discussion, which I will not do, but let me just hit some key highlights. No atmosphere on the moon, atmosphere on Mars. The temperature range and lighting conditions on the polar regions of the moon, extraordinarily challenging. Very, very long shadows that are moving quickly because the sun is shooting tangentially over the poles, right? So you have to navigate that. The fact that the moon is much closer than Mars leads to a completely different operational paradigm. You have round-trip latency on commands going out to Mars that could be 8 or so minutes round-trip. That means you can't joystick drive the Mars rovers, and so they're not a real-time roving platform. In orbit around Earth, on ISS, you have really low latency times, maybe less than a couple seconds. So you can have a direct teleoperation type activity. You can do things much more in real time. In the polar regions of the moon and the moon in general, you're kind of in a middle area. You have maybe 10 to 30 seconds round trip latency time. And so we have a pseudo autonomous operation, right? Partially autonomous by way of waypoint driving. So it looks a little bit different than what we're doing in either of those other two paradigms. Plus, the environments that we're having to survive are just fundamentally different than an atmospheric body in mid-latitude, like equatorial regions. That's not where we are. So it's a really interesting challenge. The fact that no mission has really done what we're trying to do down in the polar regions and then go into the permanently shadowed regions and actually drill on this hunt for the water ice to actually understand its nature and distribution makes this a really unique mission, just one of many facets that make this overall mission quite compelling.
All right, thank you. Next question.
Thank you. Our next question comes from Marcia Smith. You may ask your question and please state your affiliation.
Hi, this is Marcia Smith from SpacePolicyOnline.com, and my question is for Thomas. When the Eclipse program started, you described this as being a program of shots on goal, where a 50% success rate was okay. But when you look at VIPER, and you seem to be very anxious to get these results. It's $200 million just for the delivery service, and I think Lori said that you're not ready to share what the cost of VIPER is itself. But it sounds like it's going to be a pretty expensive mission. So, are you still thinking in terms of shots on goal and a 50% success rate is okay? And if so, are you building a backup for VIPER just in case this is one of the 50% that doesn't make it?
I think the paradigm of taking shots on goal is really reflected in our entire plan, which is that we are taking multiple flights each year to go there, right? So we do not just take one or two kind of on a time scale of multiple years. We take multiple, and especially at the very beginning here, I do believe we all need to recognize that we're taking more risks, and what I try to communicate in that is that we're taking more risks, whether the 50-50, of course, I know John and his team will do absolutely everything, even the first of his flights, to get there and do so safely. We stand if many people around are standing ready to kind of support however we can, to enable. At the same time, this is a commercial development that we're keeping our hands off. And yes, we are taking also in this one, in this delivery, we're taking more risks at the programmatic level for sure, but also technically relative to our oversight and so forth than we would take otherwise. This is a different kind of program, and we're going forward. We have, in some cases, on the Eclipse instruments, we have talked about spares where that is viable. We can do that. In the case of VIPER, we're certainly not developing a hot spare to go. That is not in the cards. We're not doing that. But I do want to just confirm that Eclipse program is a different kind of program. We believe, of course, we believe, of course, that the capability of our companies will make this program successful overall and make this flight successful.
And this is John Thornton. If I could just add to that, certainly from a company perspective, a 50-50 risk profile is far too risky for us as a company. So we are doing everything we possibly can to get that much, much, much higher than those kinds of odds. And that is why we work with some of the best in the industry who have done extraordinary missions time and time again. We will be picking one of the most reliable launch providers in the world. I won't say which, and we haven't made that selection yet. We will be working with partners on our reviews. at every step of the way, and we have some of the greatest partners there to get that part done. Just from a commercial side and our approach to this mission, we see the national importance of this, and we are doing everything that we can possibly do to make this mission a success for NASA.
Thanks so much.
Thank you. Our next question comes from Jeff Faust. You may ask your question and please state your affiliation.
Good morning. This is Jeff Faust of Space News. A couple of questions for John. You mentioned about the importance of precision landing. I wonder if you can give an estimate of what sort of precision requirements you're going to have for the VIPER mission. And also, this is going to be your second CLIPS mission. Will it be your second CLIPS mission, your second mission overall, or will you have additional lander missions between the two CLIPS missions? And then quickly for NASA, to follow up on an earlier question, how many of the 14 CLIPS providers responded to the VIPER task order? Thanks.
Thanks, Jeff. And first, on the first question about precision landing, our precision landing capability is to land within 100 meters of a target. And that system is actually being tested on our first mission on board the mission that will go to an equatorial region. So that's going to be a great way to make sure that system is running the right way, and we'll be using that same software and program for applying it to the VIPER mission. And then the other additional part about the precision landing is we are using the data from LRO in order to do that precise landing. But even with the amazing imagery from LRO, we also need the capability to potentially avoid hazards down on the surface. So we have an additional capability of detecting hazards as we get close to make sure that we can deliver VIPER to a nice, safe landing site that we can then deploy and deliver the rover to the pole. And then just on the second question there with the number of missions, so our first mission is Peregrine going to the equator of the moon. Second mission as of now is this program with VIPER. We are actively in the commercial market, and at this time we're not announcing a launch in between, but we certainly have a lot of interesting commercial conversations going on right now.
And Chris or Steve, I don't know if you want to address the number of people who have proposed. I think we've mentioned that briefly already.
Yeah, this is Steve, but yeah, we don't share exact number of responses. That's all part of our procurement process. But I think I'd like to just, reemphasize what both Chris and I said, that we had a healthy response from the pool of our CLIPS providers.
Thanks.
Thank you. Our next question comes from Zach Hall. You may ask your question and please state your affiliation.
Hey, this is Zach Hall from SpaceExplorer.com. From the NASA side, what specifically about Astrobotic makes the company ideal for transporting VIPER? And for Astrobotic, I guess I kind of have the answer for this, but can you characterize the scope of this mission relative to, what's already on the books? And then finally, is there any chance that ULA won't be a launch provider?
So this is Steve Clark. I can answer your first question. So as I had mentioned earlier, we had a set requirements that went out to our CLIPS providers in our request for the task order plans that the ones that provided bids gave us details on. So there were set requirements that and questions that they being the CLIPS providers had to address in their proposals. And we went through a very rigid evaluation process, looking at it from a technical standpoint, a programmatic standpoint, which includes the schedule and milestones, and also, from a cost standpoint as well. So the assessors looked at all of the bids that came in, looked at it from a technical, programmatic, and cost perspectives, and determined that Astrobotic was certainly the best choice to provide them this task order to deliver the VIPER Rover. Chris, did you want to add to that?
I'll just say that, yeah, it's when we put out a request for task order proposal, all the vendors provide their description of how they would meet our requirements, and we have an explicit set of evaluation criteria that we judge them on, and we look at what vendor both meets all our requirements and provides the best value to the government.
Okay, thanks. Next question.
I think I needed to answer the second half of that last question, if that's okay.
Sure, sorry.
So just in terms of Astrobotic, this mission is a very big deal, and we're really, really excited for it. We have been building the company for this opportunity for 13 years. That includes everything from the technology over that time to the personnel we've been staffing up with, to even our facility that can support 4 lander builds simultaneously. We are just so excited about this. Our company was built for this opportunity, and we're just so excited to have this opportunity now, and it really is another big step in the development of Astrobotic.
Okay, now we're ready to go forward.
Thank you. Our next question comes from Leo Enright. Sir, you may ask your question and please state your affiliation.
Good evening from Europe. I'm with Irish Television. I had a couple of questions, if I may. The first is targeting. Have you narrowed down in any way where you're going to land at the South Pole? Is the Shackleton crater still in the mix, or is there any particular reason why Shackleton wouldn't be considered? And I also had a question about operations on the surface. There were these amazing pictures of Russian Lunokhod drivers sitting at television screens, watching TV and steering their Lunokhod across the surface. I take it we're not going to have that level of amazing experience?
John, did you want to start out with that, perhaps?
In terms of location, I think that might be better for NASA to answer.
Yeah, this is Dan. We are right now and have been for some time studying the options, frankly, on both the South Pole and the North Pole, because at one point we didn't know which pole we were going to, and both of them are viable for answering these big water questions. But of course, most recently, as we've been looking to go to the South Pole, we have been putting all of our efforts there. What's interesting about the polar regions that maybe is already understood is that because of all the constraints, we have to create some pretty impressive tools, which we have created, to help us navigate the multivariable constraints of a solar-powered mission, right, which we are. We're actually powered 100% by solar energy on our solar arrays. Further, we have broken up the water problem, the discovery of water, into 4 pieces. We think there's 4 different ice stability regions in which the water ice can exist. And we are looking for regions in our site selection that can provide all 4 of those ice stability zones, okay? And so those 4 zones are basically permanently shadowed region, where it's possible there's even surface frosts that are present. And then, of course, Elk Cross, as an example, already showed that there's water ice subterranean right below. Then there is first 50 centimeters, which we have as our first range in there, and water ice could be there. We need to understand that. There's the second 50 centimeters, so between 50 and 100 centimeters deep, which our drill, of course, is going to go down to these levels. And then finally, the 4th area is dry areas that see the sun, that we really have very little expectation there's going to be water ice there, but we're going to check them anyhow, just as a calibration. So we don't yet have a selected landing site. And that's something we're going to choose going forward. But we have tools built to help us find the optimal solution based on the capabilities of the rover and these 4 zones that we want to make sure we hit to provide a complete composite picture of water ice in a polar region.
And just on the second part of that question, in terms of the experience, I can speak to the lander side, and I'm sure NASA could add from the rover side. The unique opportunity that is so exciting about the moon is that these missions will look different than what we have seen at Mars and other destinations. This will be more like the Apollo missions and more like the Lunokhod mission that you mentioned, in that data is coming back at a much faster, more real-time rate. And that means that when we land, the first imagery is going to come moments later when we're working to deploy the ramps to send a VIPER on its way. We'll be able to see pictures and eventually video of that occurring. So it's just going to be a much more real-time, immersive experience, and I think that's and all other lunar missions.
And this is Dan again. On the VIPER side, we have been exploring interesting ways to engage with the public where we actually could provide tools that the public can actually follow along with the mission live and create their own viewing panels. Of course, they can't control the rover, but they can monitor what's happening, pull down video, look at various statistics, and so forth that we would make available safely on the other side of a firewall for a level of engagement like you have never seen before. So we're exploring a bunch of those ideas too, since we now can do that type of thing.
Okay, thanks. And someone has an open mic, if you could check that. And we are ready for our next question. We're running out of time, but we just have a couple left.
Thank you. Our next question comes from Russell Pounds. You may ask your question and please state your affiliation.
Good morning. This is Russell Pounds with Pacific Rim Media in Anchorage, Alaska. And I've got a question and maybe a quick follow-up to maybe Dan or John at Astro Robotics. I'm curious, when the light goes on for the business community, for the value of this kind of exploration, how can it most directly impact people on Earth is the kind of thing I'm thinking about.
Yeah, I'll come out first from the commercial side. One of the most important things when you're looking at a resource in any destination, whether it be here on Earth or on the moon or anywhere else in our solar system for that matter, one of the most important things to determine is how much of that material is there, what concentration it's in, how do you potentially get at it, what are the chemical or mechanical or whatever processes you need to isolate it. And that is so important because that drives the architecture that you need to then extract that material and turn it into rocket fuel or oxygen to breathe or even water to drink. So it's incredibly important to do that. And that's why, from a commercial perspective, this mission could be totally groundbreaking. This mission would probably be referenced in business models that would start popping up after this mission comes out, saying, hey, maybe we could actually do this and it could work, but we really need to understand what concentration and how the water is stored at the poles of the moon to really kind of unlock that capability. Because otherwise it's too much unknown, too much risk, and the business community needs a little bit more certainty before big bets are going to be made in that category.
And this is Dan, VIPER PM. The idea of living off the land on any planetary body is something that's age-old. The idea that you can, just like early explorers in the United States, that you could actually, set up a camp and actually live off the land and so forth is part of the human experience. On the moon, the curiosity about the possibility of there being water ice there and then later confirmation that it's there leads to the next natural step, which is, okay, but is it there in quantities that are usable? Is it accessible or is it hard to get? Is it economical to be able to get? All of these things have been part of the planning that goes back even before VIPER to Resource Prospector and other activities that the agency and others have done to try to get those questions answered. And the thing is, even when you get those questions answered, it's going to then require effort to engineer solutions to go get them. The next natural steps. There's really strong analogs to what is done for resource hunting on the Earth itself. And so in order to get those things going so that it can lead to ultimate usability and sustaining humans on the moon, which is our connection to the Artemis program, we've got to get these questions answered as soon as possible. It's really important to get them in place so that all the follow-on work to be able to produce water at scale, if that's the eventual outcome, you know, if it's supportable by what we discover with VIPER, let's get those things moving so that we can have those capabilities in place as soon as possible.
Oh, that's great. And I think you maybe touched on that, Dan. Is the interest from the mining companies been high? Have you actually gotten people that are engaged at that level?
Almost definitely. In fact, we should not be the ones who are first inventing what it takes to explore for resources. We should be leveraging that body of knowledge of what it takes to economically understand what you have and how to access it, right? Otherwise, you would just land hundreds of drills all over the place randomly and hope for the best. That is not economical. So instead, you have to be smart and think about how much of this can you do with sensing? How do you ground truth it with drilling? How do you drill in just particular areas to make sure you get confirmation of that data? And then have a good confidence in what you're finding. That's been the case of mining and terrestrial resource hunting for hundreds of years. It's just technology keeps getting better and better such that you can do it more effectively.
And Russell, this is Steve Clark. If I can add on to what Dan said, he's exactly right. We work very closely with our Space Technology Mission Directorate colleagues as well. They are looking at various in-situ resource utilization demonstration, technology demonstration payloads to take to the lunar surface to do just what Dan's talking about, is looking at ways to actually process the water ice that hopefully we'll be able to extract. Look for ways for extraction, processing, breaking it down into hydrogen, oxygen, as been stated before. So certainly NASA is looking at how to do that in conjunction with commercial entities and academia as well.
That's great. Thank you very much.
Did you want to comment a little bit about the search for water ice and what we know and from a science perspective?
Sure. Yeah. From a science perspective, we have been studying this for about a decade or so now. We finally realized that there is water there, but not knowing what it is, where it is, what else is there with it. So we have a lot of big questions that can help us not only understand the moon and what's going on the moon, but it can actually help us understand sort of broader questions about how water has formed and moved around in our entire solar system. So I think there's some really big, exciting things beyond the question about ISRU, which is also very important. But I think from a science perspective, this is a really exciting mission to look forward to as well.
Thanks, Sarah. Okay, we're done with our last question. We're a little over time.
Thank you. Our last question comes from Anthony Colangelo. You may ask your question and please state your affiliation.
Hey there, this is Anthony Colangelo from Main Engine Cutoff. With the mission heading to the South Pole, I'm wondering if there's any communications relay requirements or if the rover will use direct-to-ground for the entire mission.
This is Dan. I think I'll take that one. The plan for the VIPER rover is to communicate direct to Earth, DTE. And we did a number of studies early on in the concepting there about whether or not it would make sense to use you could have an orbiting relay, or you could use the lander itself potentially as a relay. And we looked at those, and first of all, we didn't have confidence, at least with what we knew at the time, for what was manifested in the idea of a overhead orbiting relay. Plus, that only has windows of opportunity when it's overhead, so you have limitations there. And with respect to using the lander as a relay, that has a lot of attractive possibilities too. But what's interesting is when you take into account the topography in the polar regions, you actually have cases where you do not have line of sight back to the lander, but you do still have line of sight back to Earth. So it's actually, in some cases, more constraining to use the lander as a relay than it is to communicate back to Earth. Now, of course, that comes with certain complexities. You are beaming a bunch of energy back to Earth very tangentially to the surface because Earth is very low on the horizon when you're in a polar region. So we're having to compensate for that by carrying a good amount of power margin in our radiation ability, how we radiate the energy, the radio frequency signals back to Earth. But yes, we're going to plan to do direct to Earth.
Okay, we actually have one final question. We can take that briefly, and then we'll have to wrap up.
Can you hear me?
Is this Joey?
Yeah, sorry, I didn't know I was selected.
Sure.
Thanks. Yeah. I was wondering how is NASA going to handle the communications from the poles of the moon, and separately, will the scope of VIPER's mission be shaped or affected at all by the future, or in the future, by current negotiations on the Artemis Accords, which addresses the international law on the collection of scientific data? Thanks.
Andy, do you want to quickly talk about the communication? It must have already answered. Just want to make sure that it's fully answered.
Yeah, I don't know, is it Joey? I don't know if you heard the previous reply, but we're going to be using a direct-to-Earth communication scheme right from the rover back to Earth and not use any relay schema. The idea is, since we're a very early mission for polar region activities, we can't rely on a lot of infrastructure. In the future, of course, that'll be a very different story as you start to build up on the moon as exploration continues forward. But at first, we have to kind of take care of our own needs to make sure that we can get the job done.
And the question about the Artemis Accord, of course, has a simple answer, and it's precisely those kind of activities that were outlined, especially by John and others, that relate to the commercial potential and commercialization of some of these capabilities that are really covered under that accord. And so in that sense, it's highly consistent with that and directly related to it. Thank you so much for all the great questions.
Thanks.
Okay, thank you, everybody. That's going to conclude our telecon for the day. If you want to listen to it again, there is a replay that will be available in about an hour, and you can dial 800-570-8796 for that. I'll repeat that one more time. 800-570-8796, and you can hear a replay of this call for about a month. There is also a NASA press release that is up at nasa.gov, and a lot more information about VIPER and the CLIPS program at nasa.gov/VIPER and nasa.gov/CLIPS, which is CLPS. I want to thank everybody for participating, and this will close out our call for now. Thanks.
Thank you. That concludes today's conference. You may disconnect at this time.